and I will also give you I will also try to give an introduction on forces in space. With that, we will finish first and second unit. Okay, so we'll have to hurry up a little because there are 6 units. We have only finished 2. Okay, so everyone, so this one is, I think, pretty clear. You convert this into 2 problems and then you add it. Okay, and this again you can convert into 2 problems, 10, and then only the UDL and then add. All right, this again you can convert into 2 problems and add it. Okay, so I'll leave it to you guys to do your homework. Okay, just one problem I will solve just as a recap of what we did in the previous class, because we had it the previous class 3 days back. All right, so you can just draw this diagram. Finished drawing? Are you finished? Can you see my screen?
Yes, ma'am.
All right.
Yes, ma'am.
Okay, so how will you solve this? First of all, there are 2 reaction forces. One is RA, and of course, I'm not going to write the and moment with respect to point A. So if I want to calculate that, what will be the value of RA? RA will be equal to UDL 3 multiplied by 4 is the load plus 8. Okay, is going to be my, so 12 plus 8 will give you 20 kilonewton. Any doubts in this?
No, ma'am.
Okay, good. Next is moment with respect to A. So let's do the UDL first, which is 3 kilonewton per meter. So 3 multiplied by 4 is the load multiplied by perpendicular distance. What will be the perpendicular distance? From this point to the midpoint of the UDL. All right, so that is 3 plus 2, 5. Any doubts in this?
No, ma'am.
And
No.
what will be the sign? It is a clockwise direction, so I'm going to put minus. All right. Next is minus 8 into 2. So this is your moment. So minus 60 minus
76.
kilonewton meter. Any doubts?
No, ma'am.
All right.
No, ma'am.
So let's go ahead with simply supported beam. All right. So you know what? I will share my full screen. That will be easier for me. Let me know if this is more convenient, okay? You all can see my screen?
Yes, ma'am.
So if I put the PPT, what do you see? I'm sharing my PPT. Are you able to see the PPT now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
You're able to view my PPT?
Yes, ma'am.
Yes, ma'am.
Okay. So now next one is about simply supported beam. We finished cantilever. All right, let's go to simply supported. Concept is same, okay? So this is the first one that we'll be seeing. All right, so we have, you can draw the diagram, please. Write the heading as simply supported.
Ma'am, excuse me, 1 minute. Value for the SI unit for MA is kilonewton meter, ma'am.
For moment, yes,
Yeah, kilonewton meter.
yes. All right, please draw this diagram. Did you finish drawing?
Yes, ma'am.
Okay. Now, are you able to see my iPad screen
Yes, ma'am.
Yes, ma'am.
and the PPT both?
Yes, ma'am.
Okay, good. So, if I draw the reaction forces, first one is a fixed support. So, you will have reaction in two directions. Yes? All right. So, I'm going to name this as RAY and RAX. Okay. And here you will have only one reaction support, which is RBY. No horizontal, because it's a roller support. Any doubts still here? Can I proceed?
Yes, ma'am.
All right. So
Yes,
now,
ma'am.
what is the next step that you guys have to do to find out what is the value of RAY, RBY, and RAX? See, there is no reaction moment. Reaction moment will come only for a cantilever beam, which is a fixed support fully. Okay. This one is known as the hinge support, and this is known as roller support. For roller support, only one reaction will be there. Reaction force. For hinge support, there will be two mutually perpendicular reaction force. Okay, we have already studied this before. Now, in order to find out the reaction forces, what are you supposed to use? Use all the equilibrium equation. That means sigma fx equal to 0, sigma fy equal to 0, moment with respect to any point. I'm going to take point A equal to 0. All right. And you all know what is the sign convention that we are following. Up, okay, it's not visible. Up is positive, down is negative. Okay. Anti-clockwise is positive, clockwise is negative. In the PPT, if you see, we have assumed clockwise as positive and anti-clockwise as negative. Okay. So you can assume, see, if different textbooks will assume differently. All right, both are correct. Okay, the reason why I'm teaching you like this is because in the next subject that you will learn in the next year, that is strength of materials, okay, this is an easier, convention to be used when you're solving bending moment and shear force diagrams, okay, that you will know in the next year. All right, so now coming to the horizontal forces, there is only RAX, which is equal to 0. So every time I am excluding this. Okay, now come to Fy. So if you take Fy, how many forces are there? You have Ra upward force plus RBY, and I'm going to equal to all the downward force because anyway it's going to be. Are you able to follow me? All right. So now you have two unknowns in this one and this one, and you have two equations. You can solve both the equations and find. So moment with respect to A equal to 0. What are the moments with respect to A? You have how many forces? Three forces are there. RAY. So RAY passes through the point A, so multiplied by 0. Then you have W multiplied by L by 2. And it is a, what moment is it? It's in this direction. It is clockwise, so minus. Okay. And then you have RBY multiplied by L. And it is in which direction? It is anti-clockwise direction, so you will get plus here equal to 0. All right, so with this equation you can easily calculate what is RBY, which is nothing but WL by 2 divided by L. So it is nothing but W by 2. Substitute this in this particular equation. Okay, so if you substitute it here, then you will get RAY as W by 2. So what are the reaction forces we have? The reaction forces that we have, RBY value is W by 2, RAY is also W by 2. Did you understand how we are solving this?
Ma'am, ma'am,
Yes. Please go ahead. You have a doubt? What's the doubt? Do you guys have any?
ma'am,
Yeah.
yeah, ma'am, that RBY is equal to W square L by L square only, no, ma'am.
W?
The RBY is equal to W
RBY
square L
by no, not W square.
by
It is WL by 2.
by by oh, L by 2, L square not, no.
How will L square come? Wait, let me do it step by step. This gets cancelled completely. You take this part, that side. So what will you get? RBYL equal to
Yes,
WL
yes,
by 2. This and this
yes,
cancel it.
ma'am.
Answer is W
Yes,
by
ma'am.
2. Okay, clear now?
Yes, ma'am. Yes, ma'am.
Okay, so shall we solve some problems? Okay, now all of you can switch on your videos. All of you can switch on your videos. I will wait for 10 minutes and I will show you the problem that we are solving. Yeah, let's solve. Only one problem is there. Okay, wait. I'll give another problem. We will solve two problems in class. All right, and you guys can yeah, draw the problem which I'm drawing. Let's do that one first, and then you guys can do the UDL. Okay, and then I will give some problems for homework. want one with the point load. Okay, let's do this only. Let's take a simple problem for now. Guys, I will not give you a break. Okay, we'll go ahead directly so that I'll finish by, instead of finishing at 12:45, I'll finish by 12:15. Not 12:15, 12:30. Is that okay?
Okay, ma'am.
All right, so this is the problem we've got. You guys want me to share only the iPad? Or is this okay? You're able to see the iPad screen now or just the screen?
No, ma'am. No, ma'am.
No, right? Okay. Yeah, everybody please switch on your videos, yeah? I would like to see you guys. Nathaniel, are you able to follow since you joined late?
Yes, ma'am. Ma'am, I joined at the beginning.
No, not for this class, in this semester.
Yeah, yeah.
Ashwin, heavy rain. Okay, no problem, Ashwin. You can switch it on next class. Okay, so let's begin. What are the reaction forces? I am going to exclude the, for roller support, it is one reaction force. Here you have one, so I'm just going to take it as RB and RA because there are two forces here, horizontal as well. But since there are no horizontal forces, I'm going to skip that. Okay, so you need to find what is RA and RB. So all the vertical forces equal to 0 and all the moment with respect to any point, let's take point A equal to 0. This is point C and D. All right, so let's solve. So RA plus RB is equal to 48 plus 40. All right, so you guys do the maths. What is that noise? Okay, okay. Wait a minute, I think I better stop presenting and present my iPad alone. Okay, so now moment with respect to A is equal to 0. So RA will become 0. All right, then you have minus 48 into 1 minus 40 into 3 plus RB multiplied by 6. All right, so 6 RB equal to 48 plus 40 into 3. Tell me the value of RA and RB. Hurry up, do it fast. What is the value of RA and RB?
Ma'am, RA would be
28.
20. Sorry, RB would be 28 and RA would be, what to say, minus. Wait for.
Substitute this here, and you'll get RB.
RA 60, ma'am.
Okay, good. So RB is 60. No. Wait. RA is 60. RB is 28. Okay, I think you guys are pretty clear with this. All right, can we do the next one? Let's solve the next one. We'll solve one UDL and then we'll go for a complicated one. All right. This is the form. This is the diagram. You all can write it down. Similarly, all the vertical forces equal to in y direction equal to 0 and moment with respect to A equal to 0. So here you'll have to write RA plus RB equal to, what are the other forces you have? 5 multiplied by 4, 12. Okay, similarly you'll have moment. So with moment, RA multiplied by 0 minus 5 into 4 is the force, and perpendicular distance is 1 plus 2. I hope you're following. And you have RB, which is a positive force.
Ma'am, 5 multiplied by 420, right?
Yeah, you can do the maths.
You wrote 12, ma'am.
Oh, here. Okay, sorry. RB multiplied by 6 plus 1, 7 equal to 0. So with this equation, you can calculate what is RB. Substitute this here, you will find RA. Can you do it? This is somehow not clear. Is it clear, guys? Are you able to follow? Students, can I get some response, please?
Yes, ma'am.
Ma'am, RA is equal to 11.42 and RB equal to 8.57, ma'am.
That was fast. RA is equal to 11.53 kilonewton and RB is equal to 8.57. Good. The rest of you, are you getting the same answer?
Ma'am, 43, ma'am. 11.43, ma'am.
No, it's 11.53.
Ma'am, no,
Ma'am,
ma'am.
then RA plus
11.53, ma'am.
RB will exceed 20, ma'am.
Yes, ma'am.
What is RB did you get? What value did you get, RB?
8.57, ma'am.
Yeah, substitute that in the next equation. So 20 minus 8.57 is how much?
11.43, ma'am.
11.43. Okay. All right. So let's go to the next question. Just a minute, guys.
Ma'am, is that our book, ma'am? Like our syllabus?
Yes, that's your textbook.
Oh,
Actually, you were supposed to get all the textbooks in when you were here. I mean, they generally provide first year textbooks, but so happened that okay, we'll solve this. Okay, the next question, I want all of you to do it on your own. Please write it down. And then we'll go to overhanging after this, okay? All right, please solve this one. You'll have two reaction forces here.
RA is 80 and RB is 50, ma'am.
Yes, very good. Who was that who answered just now?
Joel.
Joel. What about the rest of you? Are you getting the same answer? Pretty simple. RA plus RB is equal to 50 plus 40. 10 multiplied by 4 is 40 plus 40. All right. I'm just going to give you the concept. With respect to A, moment with respect to A equal to 0. So RA multiplied by 0. All right. Then you have minus 50 into 2. All right. Then you've got minus multiplied by 2 plus 2. All right. Minus 40 into 6. And then you've got plus 50 multiplied by 10 equal to 0. Hey, where is RB? Wait. RB multiplied by 10 equal to 0. So in this equation, you can calculate RB, which is 50 kilonewton. Substitute it here, you will get RA as 80. You guys are clear?
Ma'am, how did the 2 into 2
Yeah.
plus 2?
You're calculating moment with respect to A. So from the midpoint of
A,
the
ma'am.
UDL till A, what is the length?
Oh, yeah, ma'am. 4. Yes. 2 from the first, from the
Correct,
2
Avikash.
from the next 4 part. Yes, ma'am. Yes, now.
Finished, guys? Is everybody done? What about Akash?
Yes, ma'am.
Let's do the next problem. I think let's take an overhanging beam. So this is an overhanging beam. Can you guys solve it? Same concept. Only for moment you will have to think a little. I'll give you 5 minutes. Solve this question. Find the reaction forces. There are two forces, a UDL and a
Ma'am, RA2 and RB12, ma'am.
good. I'm going to wait for another 2 minutes for the rest of them to finish. Then I'll solve.
Ma'am,
Yes.
ma'am, can you please teach me how to calculate the moment once again?
Yeah. I'll do that. All right. See, those of you who have finished, I don't want you to sit idle, so just draw this diagram and then I'll teach the previous one. So this is RA, RB, these are the supports. This is 5.5 kilonewton, and you have 2 kilonewton here. Okay, and you'll have a UDL, which is 2 kilonewton per meter. Okay, can you do it? Oh, sorry, just write it down. Done? Okay, let me teach how to do this. Summation of Ry equal to 0. So you have Ra plus Rb is equal to 2 plus 2 multiplied by 6. Do you have any doubts in this? No? Is it clear?
No, ma'am.
Good. Next is moment with respect to A equal to 0. So Ra passes through the point A, so that will become 0. Let's take the UDL next. So the UDL is it is in this direction, so minus 2 is the load. And what will be the perpendicular distance? Midpoint of the UDL till the point with respect to which you're calculating moment. Full length of the UDL is 6. So midpoint will be 3. Then minus 2 multiplied by 6 plus RB multiplied by 4. Is it clear? Check your answers. Is it clear? Who asked me the doubt? Someone asked me to explain the moment again.
Yeah, ma'am, I am the person.
Richard, are you clear? You can
Yes,
ask. If you still have doubts, I'll explain again. Clear? Okay. Shall we do the next one? What did you get the answer? RE and RB?
Ma'am, how to find the direction of this UDL, ma'am, that you have mentioned minus?
See, the UDL is whenever it is like this from top, okay, it is downward force.
Yes, ma'am.
If it is like this, it is upward force. Okay, so you're calculating with respect to this point and the force is downward. How will the beam bend? Downwards.
Downwards. Yes,
This is what? Clockwise direction, right?
yes, ma'am.
So clockwise is a negative.
Okay, ma'am.
For RB alone, it will be positive. Because for RB, it is upward direction.
Upward force. Yes, ma'am.
So it is anti-clockwise. This is
Okay, ma'am.
clockwise.
Okay.
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 What did you get the answer? I think RA is 2. What did you get the answer, guys? RA is 2 kilonewton. RB is 12. I think so. What did you get, Joel?
Yes, ma'am. RA is 2 and RB is 12.
Good. Okay, so I want you guys to take 5 minutes and solve the next question. Then we'll go to the next topic. I'll just go get some water. Okay, you guys can, those of you who have finished can take a break. I'll be back. So did you guys finish solving? What is the answer? Richard, did you understand?
RA is 7.5.
Only Joel is answering. Joel, I think you should give some time for the others.
Okay, sure, ma'am.
Richard, you got the answer?
Ma'am, I think RB is 4.5 and RA is 9.5. As per the calculations on that type.
4.5 and RE is 9.
9.5. Is that correct, ma'am?
Let me check. Oh. Who else got the same answer? Okay, Abhikash, you finished? What about Aditya? Alan?
Is that correct, ma'am?
I don't think so. I'm just checking if someone else got the same thing or not. Astil? What about Akash? Brian? Marcus? What did you get?
Ma'am, I got 10.9 and 3.6.
10.9 and 3.6. Okay, that is also not correct. Jerry? Jason? What happened? You guys are not there? The names that I called, there is absolutely no response. Astil, are you there? Akash? You guys should respond when I'm taking your name. Abhikash, you finished? Am I audible? Ryan? What happened to these guys? I'm going to mark you absent then if you don't respond. There is a chat box. You can respond through that. If there's an issue, Astil has responded. Astil, what's the answer you got? Yeah, Marcus, I'm asking. You already answered. Mukesh?
I'm getting 13.2 and 4.3, ma'am.
Okay, that's also not correct. Nathaniel? Astil, you're still doing. I gave you 15 minutes time, man. Nathaniel, any idea? What's the answer? Okay, you can give the answer in the chat box, Brian. What happened to Akash? No response from your side.
Ma'am, I think I'm wrong in substituting the values correctly, ma'am. So the idea, the calculations, I think fine, but I don't know how to substitute values, ma'am.
Okay, so Joel, what did you get? Now you can answer.
Ma'am, RA 7.5 and RB 10, ma'am.
Okay, see, I'll do it step by step. This is the answer. Okay, not this and not this. All right, so first is all the vertical forces equal to 0. So on upward forces, put it on one side, and downward forces put it on the other side. So 5.5 plus 2 is the point load, and the UDL is 2 into 5. You guys are clear till here? So what did you get the value? RA plus RB equal to how much?
17.5.
17.5. Okay, so Richin and Richard, did you get the same answer? What about Marcus? You got 17.5? You can just show yes or no. Marcus?
I made a mistake there, ma'am.
Okay, good. So now you know where is
Ma'am, I'm
where.
sorry, ma'am. I said the answers for a previous problem, ma'am. I'm doing this.
Okay, perfect. All right, next is moment with respect to point A equal to 0. All right, so now, okay, you can listen to this carefully. I'm not writing RA because it's anyway going to be 0. So let's take the uniformly distributed load first. So 5.5 multiplied by 5 is the load. What is the perpendicular distance? 2.5. Midpoint. Okay, next it is minus 5.5 multiplied by 2 plus RB multiplied by 5 minus 2 multiplied by 7 equal to 0. So what do you get? RB. 5 RB, take everything to the other side. What is the value? How much is it? 50? Are you getting this? So RB is 10 kilonewton. RA will become 7.5 kilonewton. Any doubts, guys, till here?
Can you explain the previous step one more time, ma'am?
Yeah. So this one is, I'll use another color. First, let's take the UDL. So how does the UDL look like? Like this, A, B. You're calculating with respect to A. So what is the midpoint? Is 2.5. What is the load? 2. Did I do something wrong? Yes, I have done wrong. Wait. This should be 2, right? How come no one told me? 2. UDL value is 2. 2 multiplied by 5. The length of this is 5. So 2 multiplied by 5 multiplied by, so this is the force. And 2.5 is the perpendicular distance. Are you getting it? This is clear? Is it clear?
Yes, ma'am.
Okay. Next is, let's take the point load 5.5. What is the perpendicular distance? 2. Then RB and the perpendicular distance is 5. But this will become positive because it's an upward force which will give an anti-clockwise moment. Next you have 2 multiplied by perpendicular distances 7 equal to 0. Clear? So can we wind up this topic? I will put some more problems in the PPT and I'll upload it so that you can do it as a practice. Okay, so now it is 12:15. We have 15 more minutes. I will take forces in space, the introduction on that. Okay. All right, ready? Wrote the heading? Okay. You have X, Y, and Z. All right. You've got X, Y, and Z. X-axis, Y-axis, and Z-axis. All right. So if I have 2 points here, all right, and this is my force F. Okay, so this is point A and this is point B. Point B is given in terms of x2, comma y2, comma z2. And A is given as x1, comma y1, comma z1. Got it? So any force, for example, if I take any force, all right? So force 1, say take force 1, will be denoted by x1i plus y1j plus z1k. Okay, you know that. So F1, if you take just any force, all right, F1 can be denoted in x, y, and z direction. That is the position of the force. All right. So now, in this scenario, if you take, so this is something which you already know. Okay. So now, if you want to calculate a force in its direction and magnitude, okay, how will you denote it in vector form? Till now, what we have done, we have taken a force like this. If we have a force in this direction and you've got theta, for example, and here say theta x and this is theta y. So what will be the horizontal component? And if this is F, okay, horizontal component will be F cos theta x, correct? Vertical component will be F cos theta y. Clear? F cos theta x and F cos theta y. So now, how will you denote this F? F vector can be written as F cos theta x I plus F cos theta y j. Okay, this is how you write it in vector format. Okay, so this is nothing but Fx I, what horizontal component Fy j. Can you please write this down? All right, if you have in z direction, you will get Fzk. Clear? Clear? So here Fx, Fy and Fz is the horizontal component in x direction, y direction and z direction. Okay, so if I want to calculate this is the force, this is known as the force vector. This is called as the force vector. Now, if I want to calculate, okay, I'll just write it again here. So if you take Fx as F cos theta x, the components of F cos theta y, Fz, F cos theta z. So what is Fx, Fy? So you have a force F, okay, Fx, Fy and Fz are the components of force F, okay, in x, y and z directions. Clear? Okay, so in vector format, you can write F vector, F force vector is equal to Fxi plus Fyj plus Fzk. Did you understand till here? Okay, now if I want to calculate the magnitude of the force, this is the vector. Okay, force in, okay, I'll use another, force in vector form. Okay, now magnitude of force F will be equal to, what is the magnitude of force F? So that is denoted by F. F with the bar is force vector. Clear? So this you guys already know. Fx square plus Fy square plus Fz square. Okay, and what about the direction? What about the direction? The direction, theta x, theta y, and theta z is known as the force directions. Please make a note of it, guys. So you all know what is the direction of cosine rule. So by cosine rule, you have cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Basic trigonometry.
Excuse me, ma'am. Can you go back to the previous page, please?
Previous page.
Thank you, ma'am.
Yeah. Is that clear? Done? Can I proceed? We just have 5 minutes. Okay. Done? Can I proceed? Okay, so now you need to understand what a unit vector is and what is a how do you write a force vector with respect to a unit vector. So just draw this diagram. I'll explain it step by step. See, a force can be denoted with theta x, theta y, and theta z, which gives the direction. Okay, and which gives the direction. So theta x, theta y, and theta z gives the direction, and this is your force vector. F is the magnitude. Okay, similarly, you can also write the force vector with respect to its coordinate axis. Okay, so F is given like this, and if the F passes through AB, okay, and this is x2, y2, z2. Okay, and this is x1, y1, z1. All right, so F, force vector F bar, can be given as the magnitude of the force multiplied by its unit vector. All right, so what is a unit? So here this is equal to Fxi plus Fyz plus Fzk. Okay, and this unit vector that you see here can be given as, okay, I'll write it here. Unit vector is given as x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k divided by the distance between the two, which is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Are you getting me? All right, so this is how you denote it with respect, if you have the coordinate axis and you don't have theta 1, theta 2, and theta 3. All right, please write it down. And let me know once you're done, because I need to just show one slide and then we'll close for today. You guys are done?
Yes, ma'am.
Yes, ma'am.
Just 2 more minutes, guys, and then we'll close. Okay, we'll go to the next. I'll close it. Can you see my screen?
Yes, ma'am.
Yes,
Okay,
ma'am.
just a recap of what I just taught you in this 15 minutes. Rectangular components of a force F, okay, is Fx and Fy. Clear? So you can write the force vector like this: F bar equal to F bar x plus Fy bar. Sorry. Okay. So I and j are the unit vectors in x and y axis. So you write it as this. So the vector components may be expressed as products of unit vectors with the scalar magnitude. So scalar magnitude is Fx plus Fy is the scalar magnitudes of F. So what is Fx here? Cos theta. And this will become sine theta. That is what I have taught you, how to resolve the forces of F. Okay, cos theta, that is F cos theta, and F sine theta. So if we take this as fx, with the x-axis it is theta x, and with y-axis it is theta y, and with z-axis if it is theta z, then what will be the value of fx? F cos theta x, f theta y, and f cos theta z. Okay, so the vector form of the force will be written as fxi plus fij and fzk. So you can take f common, and then this is known as a unit vector. Okay, lambda is a unit vector along the line of action of f. Okay, and how do you denote the directions? With respect to cos theta x, theta y, and theta z. So did you guys understand till here? Guys, did you understand? Okay.
Yes, ma'am.
Yes, ma'am.
Yes.
All right. So this is
Ma'am.
in terms of when you're defining the force with respect to the angle, that is theta. What if angle is not given? And the position of from where it starts till where it ends is given. You know, x1, direction of the force is defined by location of 2 points, x1, y1 to z1 and x2, y2, z2. So in this, how do you write the force vector? So in that, you have to join mn. Okay, so join mn, and your force vector will be like this, f into lambda. So what is lambda? Unit vector in this case. This is what is their unit lambda. Okay, dx dy dz by d. What is d? Okay, here d is not given. Okay, I have already made you write. D is nothing but root of dx square plus dy square plus dz square. What is dx, dy, and dz? It's given here. X2 minus x1, y2 minus y1, and z2 minus z1. So did you guys understand? Okay. So what have we done today in today's class? We have finished supports, and we have learned about how do you denote a force in vector form in two-dimensional as well as three-dimension. And there are two forms of writing of force vector. One, when it is defined by its angle, and the other when the direction is defined by coordinate system points. Okay, so in these two cases, how do you write the force vector is what we have seen. Is that clear? So with this, we close for today. I have taken 5 minutes extra. I'm sorry about that. Okay, so we'll compensate it next class. All right, so did you guys understand? Yes? Did you follow the class?
Yes, ma'am.
Yes, ma'am.
All right, so I'll upload one PPT with the overhanging and simply supported extra problems. You guys can do it in your free time. Okay, so thank you for joining in, and I'll see you on Monday? No, Tuesday.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you, ma'am. Thank you.